Band gap with HSE tutorial. Create a simulation, by navigating to the Job Designer page. Then, open the Workflow tab, and select from the list the Band Gap plus DOS HSE workflow. First, we reduce slightly the size of the grid of K points, under Important Settings. Then, open the first unit component of the main HSE Band Gap subworkflow, and inspect the Quantum ESPRESSO input file displayed at the bottom. Pay particular attention to the input DFT tag, necessary for enabling the HSE method, as well as the 3 NQX keywords, defining the mesh of Q points for sampling the FOC operator. The default settings are such that the Q grid is set to be half the size of the K grid entered by the user. After that, navigate to Compute tab, and set Compute Configuration. Here, we use one node with 16 cores on the OR16Q, since the HSE method is quite computationally expensive. Then, set the name for the job. Here, we call it HSE Band Gap Calculation on Silicon. Next, save the job. It can then be selected and submitted to the compute queue, for execution. The status of the calculation will change from pre-submitted to submitted, and then to active. When the job is finished, open it, to inspect the final results. The band gap value can be found, towards the bottom of the results page. Here, we can see the indirect gap, of about 1.193 electron volts, in excellent agreement with the experimental value for silicon. The plot for the density of states of silicon can also be retrieved, further down the page. These results are in good agreement with the published literature. This completes the present tutorial.